Hello, welcome to the first step on programming. This can be considered as the first step to programming because you start writing the algorithms. In fact, you study a separate subject on algorithms, how to design, how to analyze the algorithms. So probably after studying the data structure subject, the next important subject is algorithms, because you may study different subjects, computer networks, operating system, database management system, etc. In all those cases, you have to write the algorithms. In all those cases, you have to write the algorithms. So I think the second most important subject in computer science is algorithms. Not just the algorithms which are already given in the textbook. Maybe in your prescribed textbooks, you may find some algorithms. What people do nowadays is they remember those standard algorithms and they will write in the exam, they will get marks. But it's not that. So you have to write algorithms on your own. So by studying this subject, you have to write algorithms on your own. If you can't write algorithms on your own, then there is no meaning for that subject. But anyhow, we'll try to learn how to write the algorithms. So try to write the algorithms at this step itself. If you neglect and if you just type the programs in the textbook or in the internet resources, then you will never get the habit of writing the algorithms, and you can't write the algorithms. At initial stages itself, you have to mold yourself. You have to mold in yourself. So we will learn the algorithms. What is algorithm? What are the characteristics? And how to write the algorithms. We will discuss the notation. We will discuss the notation. Again, it is not a universal notation. It is not a universal notation. The notation which I use and which is generally used. So more than the notation, the correct algorithm is what is important. The correct algorithm is important. Correct logic is important. Don't bother too much about the syntax that is used for writing the algorithm or notation that is used for writing the algorithm. It is the logic of the algorithm which should be correct. Concentrate on only that one. So we'll discuss few algorithms. I'll throw some challenges to you. Try to write before you proceed to other modules. So the word algorithm comes from the Persian author Jafar Muhammad Ibn Musa al-Khowarizmi in 19th century. So it's difficult to pronounce the name, but the term algorithm was coined by that person in the 19th century itself. And it was published in the form of a book called as Hindu Arabic numerals. So note the name. So that means at that time itself, Indians actually contributed. Hindu in the sense that Indians actually contributed to this algorithm also. So it is the Indians who introduced this concept of zero, and then they worked on number systems. So number systems existed in India before all these things happened. But unfortunately, we don't have what is called as recorded history. So in the Hindu Arabic numerals book, the term algorithm was coined. So these are some of the definitions. So a set of rules for carrying out calculation, because initially the computer was used to do the calculations. You can say set of rules for carrying out the calculation, and a computational procedure can be taken as a computational procedure which takes some input, which gives the output. An algorithm is also considered as a finite sequence of instructions. The commonly used definition is finite sequence of instructions. An algorithm is a finite sequence of instructions that may take some input but produces the output. So input is not mandatory, we'll see, but it should result in something. So that means output is compulsory. Output is compulsory. So set of rules for carrying out calculation. Computational procedure that takes input and produces the output. The computational procedure. Computational procedure. So it is a computational procedure. So it takes input. It takes input. Takes input and it produces output. It produces output. It produces output. It produces output. So it is a computational procedure. It is a computational procedure. So this computational procedure is nothing but a sequence of steps, sequence of instructions, sequence of instructions or sequence of steps, sequence of steps to be followed, sequence of steps to be followed. So your program is nothing but algorithms plus data, algorithms plus data. So you have to organize the data. So the purpose of algorithm is to manipulate this data and produce the desired result. Suppose in the case of adding two numbers, the data is nothing but the values A and B, the values of A and B, and you will be computing the sum. So the data is nothing but A, B, C. So you are manipulating the values of A and B in the sense that you are adding the values of A and B and then assigning that value to C. And the process, the reading A, reading B, and C equal to A plus B, all those things put together is called as algorithms. So your program is nothing but algorithms plus data, but written in a form which the machine understands. So this you try to remember. So your program is algorithms plus data. So these are the essential characteristics of the algorithm. These are proposed by D. Knuth. And he is one of the famous mathematicians who contributed a lot to computer science. D. Knuth. He proposed five characteristics. Finiteness. That means an algorithm should have a finite number of steps. It cannot have infinite number of steps. You should be able to carry out those instructions. Maybe if possible manually, or at least at least by a computer. So it should consist of finite number of instructions or finite number of steps, which when carried out will give you the desired output. Definiteness, that means algorithm is a sequence of steps. Each step should be definite. That means it should be defined precisely. There should not be any ambiguity. C equal to A plus B means add the values of A and B and assign it to C. It should not be something else. So assigning value of C to A or B. So like that, there should not be any ambiguity. So C equal to A plus B means add the values of A and B and assign the total to C. So every instruction should be precisely defined. There should not be any ambiguity. Next, effectiveness. That means all the steps should be carried out within a time limit. This time limit will vary from program to program. Maybe for simple programs which you write, you need not bother too much about the time. But suppose your software is controlling the furnace temperature. So if it has to control the temperature, if it has to keep in that limit, suppose if the temperature increases by 2 degrees. So if it has to be reduced by 2 degrees, maybe if it has to be reduced by within a minute, it should do it within a minute only. It should give appropriate instructions to the specific hardware to say the cooling system, which brings the temperature by 2 degrees. It should happen within a minute only. Within a minute only. Otherwise, disaster can happen. So effectiveness. So it depends on the algorithm. What the algorithm is controlling. If it is doing some mathematical calculations, then if it is delayed, doesn't matter. But whenever it is controlling something, whenever it is part of the total system. So system consists of software and also the hardware. The hardware need not be in the form of computer hardware. It can be airplane, it can be furnace, it can be lathe machine, CNC machine, etc., etc. Okay, it should carry out those things within a time limit. Within a time limit, it should produce the desired result. That is another meaning of effectiveness. Desired result. What is expected? Exactly that result you should obtain. That is actually the meaning of effectiveness. Effectiveness is about result. It produces exactly the required result. Efficiency is using the minimum resources, etc. But effectiveness means it is associated with the result. So correct result should be produced. Input. An algorithm, if required, may have to accept some input. But input is not mandatory. Not compulsory. Output. An algorithm should yield some output. Maybe one or more outputs. Or maybe controlling something, whatever it be. Temperature control means it is not giving any output like printing the value of C, etc. It is controlling it. That is also an output. So if there is no output, then there is no meaning in writing the algorithm itself. Because you write it for some purpose. The purpose is to produce the desired output. The conventions that can be used for the algorithm. Please remember again, we need not be too strict about these conventions. But all these conventions, rules, regulations, etc. are for convenience only. They are for convenience. So because if two people want to communicate, they should have some common language. That common language is nothing but this notation or convention. You should understand. There should be common conventions. Okay, the way you have to write. Rules are there only for convenience. Even if you take government rules are for convenience. But the main thing is the policies behind those rules. They are important. But usually people stick to the rules, but they don't bother about the policies. So actually it is the policies that are to be implemented correctly. It's not the rules. Okay, notations or conventions that can be used for an algorithm. Similar to the flow chart. In flow chart, you have to use the graphical symbols, but here we will use the words or phrases. Start and stop indicates the beginning of the algorithm. Input or read statement that can be used to read the values. Print statement or display statement or write statement. They can be used for printing or displaying the result. So algorithm starts with start and ends with stop. Input or read statement can be used to read the input. Print, display or write can be used to print the output. The write and display are not mentioned here. If you want, you can use them. Doesn't matter. Generally used one is print, and generally used one for reading input is read. And these are some of the operators which have obvious meaning. Say plus, minus, stars, slash. They represent addition, subtraction, multiplication, and then division. So this can be used for assignment. This can be used for assignment. This can be used for assignment. Greater than, less than. So they have their obvious meaning. Okay, and then equal to can be used as comparison operator for comparison purposes. Want to compare A and B, A equal to B. That means is A equal to B. That's why we are not using equal to for assignment. This symbol is used, separate symbol. In case of C programming language, equal to is used for assignment. Double equal to is used for comparison. But whatever may be the case, for algorithms, we will use this one as assignment operator, this one as comparison operator. Similarly, not equal to, and also and or not. So logical and or not. Means it here. So for example, the values are true. So and means you should say if A and B are true logical values, then difficult to write the entire truth table here. So if it is true, then the result will be true. In case of AND. So in case of AND, if A and B are the two values, if you want to perform the operation A and B, that means here A and B are also taking the truth values. Now how these truth values computed in a programming language, there are different issues. For the time being, you just remember A takes a logical value, a Boolean value called as true, and B also takes the Boolean value called as true. In that case, Boolean and true is true. So if any of the values is false, then it is false. That means true, false, false, true, false, false. All are false only. That is logical AND. Logical OR means so it will be true except in the case where both are false. If both are false, if A and B are false, then the result will be false. Otherwise, true, false, true, false will result in only true value. Not takes only one operand. So not means if it is true, it becomes false. Not A means if A is true, then the result is false. If A is false, not A means it is true. So we'll study more about these things in C language. So for the time being, you just remember these operators. So they have that natural meaning. We are not in medicine field. We are in engineering. So engineering words, these symbols, etc., take their natural meaning. So bracketing symbols. So if you want to group some statements, you can use begin and end. Start, stop indicates the beginning of the algorithm and end of the algorithm. Beginning and end of the algorithm. Whereas begin and are used to enclose the statements, group of statements. If you want to group the statements, then you can group them using begin and end. We'll see. Okay. Next, we'll use the type of statements called as control statements. Try to understand these things because we will try to map the same to C programming language, the features that are provided in the C programming language. So control statements, as the name indicates, they are the statements which can be used to control the execution of the statements, other statements. In what way you are going to control? In an algorithm or in a program, in what way you are going to control? So if you write the statements one by one, this is one, next is 2, second statement, next is third statement. These are not just numbers, these are the statements. So if you write like this, first 1 will be executed, 2 will be executed, and then 3 will be executed. That means they will be carried out. But what happens if you want to execute this statement to based on some condition? That means say there will be some condition. If the condition is true, then you want to execute some statement, say S1, and if it is false, you are going to execute some statement called as S2. That means condition is true. So if this condition is true, then you are going to execute the statement S1. If the condition is false, then you are going to execute S2. So if that is the case, you have to go with the conditional statements. One such conditional statement, general representation, algorithmic representation, is if then else. That means if condition is true, do something, else do something. So we will expand it and we will discuss the examples also. But that is a conditional statement. That means if some condition is true, you are going to execute a statement or group of statements. This S1 need not be a single statement. It can be a group of statements. Enclosed within begin and end also. That's why this begin and end are useful. So group those statements. Sorry. The other type is you want to execute some statements. Say S3. You want to execute some statements repeatedly. That means so we'll execute, and then after that again execute the statements S3. So that means S3 is executed repeatedly. How? Now again you can do it based on some condition. So here again there will be what is called as condition. That means check the condition. If the condition is true, execute S3. Now again go to the condition. Check the condition again. If the condition is true, again execute S3. So we will be continuing to execute this S3 as long as the condition is true. So when the condition becomes false, it will come out. So this we will be doing as long as the condition is true. So if the condition is false, then we will not be executing S3, we will be going out. So it may occur at the first instance or it may occur at 10th instance, doesn't matter. So if the condition is false, then we will not be executing this S3, we will be going to some other statement. So you have these statements for implementing this iteration, repetition and looping. All are same, just different words. So, but there is some minor difference between this while and repeat until and also for. We'll see. Pause and just have a look, because these are very, very important. Not just from algorithm perspective. Control statements is one of the good features, is one of the essential features of any programming language. So only thing is they will implement in maybe in different way, but in almost all the programming languages you find if then else type of statement, while statement and then first statement, and also this repeat until or do while. It is called in C language, it is called as do while. But all these are supported in different programming languages in almost all the programming languages, but maybe some minor variations may be present. So these control statements are one of the reasons why you study these programming languages. You have to use appropriate control statement or control structure. One is you have to use appropriate data structure. The other one is you have to use appropriate control structure. Appropriate data structure, appropriate control structure. So for that purpose, you are going to study the programming language, not just for to understand the syntax and semantics. You learn syntax and semantics, nobody is going to put a garland. Okay, nobody is going to put a garland. So it is about control statements and data structures. So the expansion of if then else. Okay, here you can see if proposition is true, if the proposition is true, then process 1, else process 2. This process 1 is nothing but set of statements, single statement or group of statements. It can be just S1, can be S1, or it can be group of statements S2, S3, etc. Else, if the condition is false, then you execute these statements. Else you execute this statement. Again, this can be some other set of statements, single statement or group of statements. So these are nothing but the statements. And proposition, as the name indicates, proposition, that is the general meaning of it is proposition is something which can be true or false. So if proposition means if this is true, then you do it. So if this is true, if this proposition is true, then do it. Proposition is true, then the proposition is true, then process 1. The proposition is false, the proposition is false, the proposition is false. Though we are not explicitly mentioning false, it implies if this is not true means definitely it can be false only. So if this proposition is false, then process 2. Again, point to be noted here is if this is true, this process 1 will be executed. So after that, after executing this process 1, process 2 again will not be executed. Control goes to outside. Similarly, if this proposition is false, process 2 is executed. So after that, control goes out. That means again we will not be checking the condition. So the condition is checked only once. That's why it is conditional control statement, not loop. So repeat until. So that means repeat these statements. Again, here there can be one statement or group of statements. Process 1, process 2, they indicate only group of statements. There can be all put together. There can be only one statement, say S1. All put together can be only S1, or this can be individual S1, S2, etc., or group of statements. So you put all these statements within this one. So whatever the statements you put here within this repeat and until, whatever the statements you put here, they will be repeated. It can be a single statement, or it can be 5 statements, 10 statements, or 20 statements, doesn't matter. Whatever you put here, they will be executed. Repeat until this condition is true. Repeat until this condition is true. That means repeat. That means We will be executing these things until this condition. That means this condition is verified. So if this condition is true, then again you will be going here. Then again you will be repeating. Actually. So point to be noted here is the proposition verification of this condition is at the end. That means all these statements will be executed at least once. That point to note down, please. At least once. So at least once. These statements will be executed at least once. So statements will be executed until the proposition becomes the false, or until the proposition is true, they will be executed. When the proposition becomes false, they will come out. We'll go to this point. So we'll be going to this point. We'll be going to this point. So this is repeat. So repeat these statements until this condition is true.